2x y squared. As you can see, those are exactly the same. So the check is working. Now I'm sure that m sub y equal m with respect to x. So this can be handled easily as an exact ordinary differential equation. It will be successful to handle this problem as an exact ordinary differential equation. Okay, I want to do that. I will choose just only half of this problem. أنا هختار نص المسألة دي بس. يعني all I have to do is to consider that u, it's from my mind, I just choose a variable called u, which is going to equal to the integration of n, okay, times dx. Once you will integrate with respect to x, you will have to add a constant or another function in the other variable, which is y. يبقى إذا أنا هاخد نص المسألة بس m dx وهقدم ky. This is going to develop. This is what they do. In u will equal to the integration of m. It's going to be ln y divided by x plus 2/3 of x y to the power 3. I will integrate with respect to dx, and then I will add the function in y. As you can see, if I start to integrate this function, I will have u, which equal to ln y times ln x. الكلام ده it's going to equal to plus, I will integrate with respect to x. That's going to be 1/3 of x squared y to the power 3 plus k of y. This is the general solution of the problem if we succeeded in finding the value of ky. يبقى ده السولوشن بتاعي، ده الجنرال سولوشن. خلي بالك انا دلوقتي معايا الجنرال سولوشن، ده الجنرال سولوشن بتاعي already I have it. لاحظ ان الستبس 7 انا هعمل تشيك. I've just to choose one of them. Say the first term, I integrated with respect to dx, then I added the constant function in y, as you can see. The next step next step is to try to determine ky. How am I going to try ky? Since we already integrated the problem with dx, let's find partial u, partial y. We made the integration with respect to x. And we are assuming this is the correct solution. So if I differentiated partially with respect to y, it should equal to the value of n. It should equal to the part that's called n. Let's do the derivative once more. I will differentiate with respect to y. So I will hit the first term, which is the derivative of the first term. It's going to be 1/ln y. Then I will differentiate the argument of this logarithmic function, which is also ln y. The derivative of ln y is going to be 1/y. So I've already differentiated this part. Remark that ln x is a constant, since you are differentiating with respect to y. So this is ln x. The other side, I will start to differentiate with respect to y. So I have a constant, which is 1/3 x squared. This is a constant. Y to the power 3, once you try to differentiate it, it's going to be 3 times y squared. It means that those two terms will cancel each other, and now you have partial u, just wait, sorry, I missed this part, plus k dash of y. Because k of y is a function of y, once you are trying to differentiate with respect to y, so it's going to be k dash. At the time being, we can say that partial u, partial y, is going to equal to ln x divided by y times ln y, and this is plus x squared, y squared, الكلام ده plus k dash of y, it's supposed to equal the other part which exists in your ODE, it's supposed to equal to the n, which is len x divided by len y times y and the plus x squared plus, x squared y squared. If you remark, you will find len x y len y, which is going to equal to x squared y squared. It's exactly the same. So this is going to develop. So this is going to develop that in the k dash y الكلام ده بيساوي زيرو. دلوقتي انا عندي ان k dash y ده بيساوي كام؟ بيساوي زيرو. لان this is exactly the same. Len x y len y equal len x y len y, x squared y squared is exactly the same. There is nothing more here. So k dash y should equal to zero. That's in the k of y will equal to a constant. I will get back to the general solution. Now I can write the general solution from this step. The general solution will be, I'm going to write it here, just in a second, please. Okay, so it's going to be len y times len x plus 1/3 of x squared y to the power of 3 plus a constant, and I will move u, replace u by 0. So this is the general solution of this equation. طبعا if you want to check if this is the exact solution, just make the substitution, you will find the right hand side, the left hand side, you are going to check. So once more, let's regain the various steps. First of all, this is the n part, this is the n part. I'll take the n part, differentiate it with respect to y. I'll take the n part, differentiate it with respect to x. They both equal to each other. Voila, this is an exact ODE. Of course, I'm not going to deal with exact if I failed with solving the problem or speculating which method is going to work. Separation didn't work, homogeneous didn't work, actual doctor, linear didn't work, Bernoulli equation didn't work, so I will try to check exact solution. Once the check is okay, I will just choose one of them, left hand side, right hand side, any one of them. I will choose the left hand side, the first term, which is then y over x plus 2 over 3xy cubed. I integrated with respect to the x, so I've taken just only this part, neglected this part for the time being. I've taken this part, tried to integrate it. Since we are integrating with respect to x, we will have to add a constant in y, make the replacement, start the integration. This is the general solution. So it's very, very important to reach this point. So now I will have to find out what the value of ky. In order to get the value of ky, all we have to do is to try, since we integrated with respect to x, I will make a differentiation with respect to y. لما بعمل differentiation with respect to y, this term should equal to the other term that we neglected from the beginning. يبقى انا بدات ان انا اعمل التشيك بتاعي. لما عملت التشيك بتاعي وعملت differentiation partial derivative with respect to y, I end up having this equation. I've tried to compare this part with the neglected one, which is then x divided by y and y. As you can see, the terms are the same. So now we will have to consider that k dash y equal to 0. We are being sure that ky equal to a constant. I made the replacement, I have the general solution. Okay? تمام يا باشمهندسين؟ Everything is okay? Okay, perfect. Let me get rid of such a thing. Okay, let's see how it's written. Here we go, here are the steps. See the problem again once more. This is the n part, this is the n part. Okay, here is m as a function of x or y. Okay, here is m as a function of x or y. Since m is multiplied by dx, let's get dy and get my, or partial m partial y. Similar manner, we have to get partial n partial x. As you can see, we are both the same. So the trick is working. It's an exact differential equation. I can solve with the method of exact to treat this problem. I will just consider one side of these sides. Let's consider the m part since we are integrating with respect to x. Let's put a constant in y. This is how it's going to be done. Integrating with respect to the x is going to be constant. So all I have to do is to multiply x times this part. This one also is going to be very, very simple. Integrating with respect to dx. So it's going to be x to the power of 2y power 3, as you can see. We are integrating with respect to x. We will have to add a variable or a constant in y. Once we are everything in place and we are settled, I will try to make a derivative for this function, but with respect to the part that I have neglected, which is y. We'll try to get partial u, partial y, to determine the value. This is u. Once you try to differentiate this part with respect to y, len x is going to be a constant, len y is going to be 1 over len y times the derivative of the angle, which is going to be 1 over y. Differentiation with respect to y will involve the y to the power of 2, so it will cancel the 1/3. You have k1 dash of y, the next step. Okay, this is done. I will have to compare this part with the n part. This is the n part that I neglected in our integration. They are all the same. K dash y equals 0. That's the ky will equal to a constant. So now I can obtain the solution. This is going to be the solution of our problem. So replacing k1 by a constant, replacing k1 by a constant, just a second, and replacing u by 0. So this is the problem that we are talking about. This is the solution, or final solution that we are talking about. This is another problem. If you want me to solve it for you, I will solve it. I know I've given you a lot today about ODEs. Let me take the chance, since we are all here together, and I will solve this problem, and it is enough for us today. Okay? But give me the chance to solve this with you. It's going to help you out to make everything in order. Okay, perfect. Once more, nowhere it's not separable. As you can see, there is here addition between various terms. Remark, if this part does not exist, the negative y, if it is not found, the problem will be very easy to use or to solve. But the problem is, we can't do that. Okay, let's check. I will consider this part as m and negative x as n. Now I will try to make the trick. I will bring n sub y, which is going to equal to, this is multiplied in x, I will differentiate it with respect to y. 3x squared ln x plus x squared, it's all a function in x. So once you differentiate with respect to y, the derivative will link to this part is going to be 0. I have negative y. Its derivative is going to be negative 1. In a similar manner, for the n, I will try to get n, I will try to get n differentiated with respect to x. Once you try to differentiate this part with respect to x, you will have negative 1. So at the time being, you have my equal n sub x. My equal n x. So this is gonna work. This is an exact, as you can see. This is an exact ordinary differential equation. بالفعل ينفع أن تكون exact ordinary differential equation. Choose by yourself. What do you want to integrate? Do you want to integrate this part with respect to dx, or just only to integrate negative x to y? Of course, I'm going to take a smaller part in integration. So I will consider now that omega is going to equal to the integration of negative x dy. Since I'm integrating with respect to dy, I will add another variable in x, as you can see. Okay, so now I'm suggesting that the general solution will be u equal to negative xy plus some function in x, as you can see. So this is the general solution. This is our general solution. U will equal to negative xy plus k of x. More than perfect, guys. More than perfect. Folks, are with me? Now, I need to find out the value of kx. Since I'm integrating with respect to dy and I'm seeking to determine the value of x, I will differentiate this problem with respect to 2x. Let's make the differentiation. يبقى ده معناه ان partial u partial x will equal to. Once you are going to differentiate with respect to x, you will have negative 1. And then for this part, it's gonna be k dash of x. Let's compare the results with the n part this time. يبقى انا هاخد ده واروح اقارنه بالn. الn already بتساوي 3x squared ln x plus x squared minus 1. As you can see, negative 1, negative 1. Okay, but in the solution, we don't have 3x squared ln x plus x squared. Okay, so this part must equal to k dash of x. Now I know the value of k dash of x. Probably k dash of x supposed to equal 3x squared ln x plus x squared. If I integrated this function and now I have k of x, all I have to do is to replace it here and I have the general solution. Okay, let's do that. Let's integrate this part with respect to x. So I will integrate both sides with respect to x. Okay, let's do the integration. When I integrate this part, it's going to be k of x. Like, how to integrate this part? This is going to be done using integration by parts. ما اقدرش اكمل تكامل عادي لان عندي function 3x squared times ln x. يبقى اختار one of them to be integrated and the other part will be differentiated. So all I have to do, oh wait, this is the second case in the integration by parts. I will have to integrate ln x and differentiate 3x squared. Okay, no, I don't know how to integrate ln x. Okay. Then yes, exactly right. Now you read me, right? Now I'm obliged to integrate 3x squared and then differentiate ln x. The reason is simply I don't know how to integrate ln x. I'm very good in differentiating ln x. If I want to integrate 3x squared, so it's gonna be x to the power of 3 times ln x minus integration. The function that I integrated, which is x to the power of 3, will be times the derivative of ln x. The derivative of ln x is going to be 1 over x. Then I will do this integration for this part. Don't you forget that you already have x squared, which its integration simply is going to be x to the power of 3 divided by 3. That's then x to the power of 3 times ln x will equal to negative x power 3 divided by 3 plus x power 3 divided by 3. So those two parts will be cancelled together. Don't forget the constant of integration. That's in k of x from all this. Now I know that k of x, which is going to equal to x to the power of 3 times ln x plus a constant. يبقى إذا السولوشن بتاعي for the time being in u الكلام ده بيساوي negative x y. I will replace k of x to be x power 3 times ln x plus a constant. You already know that the u or omega that we are speaking about, it's just I can just a second, sorry. I can move it and it's going to equal to 0 زي ما شفت انا عملت التشيك، اتاكدت انه مظبوط اكزاكت، اخترت الجزء الاسفل سواء كان الليفت هاند سايد او الرايت هاند سايد. انا اخترت على طول سوري الفيرست تيرم والسكند تيرم، اخدت السكند تيرم integrated with respect to y, left k of x. This is general solution. Once then integrated, I've tried to differentiate it with the other variable. I make an integration with respect to y, I make a differentiation with respect to x. Comparing this part with the m part, now I have the value of k dash. I will integrate with respect to x. I have integration by parts. See, while I'm moving, I have integration by parts. It will be integrated. They cancel. The terms will be cancelled all together. The remaining term, that's k of x will equal x power 3 times the x plus c. All I have to do is to make the value of kx, make the substitution, and I have the solution. Okay? As I told you, it's very, very simple. Once you start that, here is m, here is n. The check n1 equal -1, n of x equal -1. Both of them, the condition is satisfied for this ODE. I will say that w will equal the integration of mxy dy plus k2 of x. Once you replace n by negative x to integrate to y, it's going to be negative xy plus k2 of x. I will make the derivative with respect to the variable that I didn't integrate to. I integrated to y, I will make a derivative with respect to x. I will end up having negative y plus k dash. Once you try to check the value of this part with the m part, you will find negative y equal negative y. So this value must equal k dash from here. Now I know that k dash equal 3x squared, then x equals x squared. Integration with respect to x. This is going to be integrated by parts. Once you initiate the integration by parts and finish it, you are once more. Okay, those two terms will be cancelled. K of x already know. I will make the substitution that I told you about. This is the omega. I will replace omega with 0. Okay, and I will have my solution. Thank you very much. I will stop here. Next time, I will speak with you about the linear ODEs, the methods of solution, inshallah. Thank you very much. I appreciate so much the time and the effort that we put all together today. I hope the parts that we spoke about today is clear for you, and I'm very, very thankful for the time that you spent with me. Thank you very much. I appreciate it so much. شكرا يا شباب. انا فعلا مقدر ان انت خدت محاضره النهارده، هي معلش هي طويله شويه اكتر من جزء، لكنها محاضره مفيده جدا ومهمه. شكرا جدا جدا. اشوفكم على خير ان شاء الله المره الجايه. شكرا.